Hello, this is Mrs. Hickman, and for this video we're going to be going over rectilinear motion, which is just motion at which an object is moving in either direction along a coordinate line. So this is review. So summary of derivatives. S of t is the position function, v of t is the derivative of that, and a of t is the derivative of the velocity. So this is all instantaneous. Instantaneous velocity is the slope at a specific time, and the sign gives a direction, whether it's moving left or right, and then acceleration is the rate at which the velocity changes. Okay, so we have this displacement graph, so this is S. So horizontal line means it's staying still, which there really isn't any. So what's happening here, when S of t is increasing, that's when the particle is moving right, and when it is decreasing is where the particle is moving left. So if you were looking at the velocity graph, this would be where velocity is above the t-axis, and then it would cross here, and then right here is where the velocity is going to be below the t-axis. Okay? Alright, so the velocity. Yeah, oh, and it's changing directions for the position function right here, which is where velocity crosses. As you can see right there, that's where it crosses. So just to review, average velocity is the secant line, which is going to be S of B minus S of A over B minus A. Okay, as I said here, so when velocity is above the t-axis, it's moving to the right. When it's below the t-axis, it's moving to the left. And when it's at 0, that's when it is changing direction. Speed is going to be the absolute value of velocity. So if you were to draw this one, you would just bring this point right here and then draw your graph like so. Speeding up and slowing down, we'll get to that. Okay, relating v of t and a of t. So positive slope, that means acceleration is above the x-axis. It's 0 right here because the slope is 0. Now acceleration is below the t-axis, and then it crosses at 0, and now it's above the t-axis. Okay. Acceleration graph, so you just can kind of, I just already drew that on the other one. Speeding up and slowing down. So when the signs of velocity and the signs of acceleration are the same, it's speeding up. When they are opposite, they are slowing down. Okay, so we will do an example such as that. So if you could see this really quick, you got your velocity graph here. I'll just do it really, really fast right here. So you have velocity. So from 0 to 5 or 0 to 15, velocity is positive. So that's positive velocity. And then from 15 to about 29, it's negative. And then it's 0. Now you're looking at acceleration. Okay? So from, we'll say 0 to, I don't know, 3. 3. So velocity is positive, so is acceleration. Then from 3 to 7, velocity is positive. Acceleration 0. Then from here to here, you have a negative slope, so it's negative to about 23. Acceleration is negative, so negative slope. Velocity is negative. And then at 25, probably could make that 25. Velocity is, so 23. Yeah. So you got 0 to 3. And then 3 to 7. 7 to 15. 15 to 23. And then 23 to 25, so that's going to be negative, and that's positive slope. and then this line will be at 30, and you got the root 0. Okay, so here, so it's speeding up. Speeding up, well, the signs are the same. So from 0 to 3, union, 7 to 15, union, and I think that's it. That's it. Slowing down is going to be from 7 to 15. And then 15 to 23, and then 23 to 25. Okay, so you're just writing down the t values. These are not coordinates, these are intervals. So you're just looking at the t numbers right here. Okay, so let's do an example. Okay, so first we're going to find the instantaneous velocity at any time t. So that's just finding the derivative. So v, do v of t or just v? That's going to be 6t squared minus 42t plus 60. Acceleration, and then you put meters per second. Acceleration is at 12t minus 42. When is the particle at rest? This happens when velocity equals 0. So we're going to do 0 equals 6t squared minus 42t plus 60. Okay, so we're going to factor out a 6. All right, so we got t squared minus 7t plus 10. Okay. Factors of 10 that add to get 7 are 5 and 2. If you want a review of the cross method, you got A times C. So AC, B, A, F1, F1. So AC is going to be 1 times 10, which is 10. B is negative 7. So you need factors of 10 that add, because it's positive, to get negative 7. And A is 1. So that's going to be negative 5 minus 2. So you got t minus 5, t minus 2. Okay, so zero product property. So 6 can't equal 0. So you got t minus 5 equals 0. C minus 2 equals 0. So the particle is at rest at t equals 2 and 5. Now this value right here are the critical points from the last section we did. This is where the first derivative is equals 0. So this is the same as finding critical points. So now we're going to be describing the motion. And we're going to be looking at when it's changing direction. So first things first, let's see when the particle is moving left and right, which is equivalent to finding out when a function is increasing and decreasing. Okay, so we're going to do a sign chart. Let's put our derivative down here again. So v is 6, t minus 5, t minus 2. So we're going to do a sign chart. Starting at 0, and then our critical points were 2 and 5. Okay, so f prime, pick intervals. You got 0 to 2, 2 to 5, and 5 to infinity. So f prime, so pick a number between 0 and 2, f prime is going to be 1 minus 5, 1 minus 2. A negative times a negative is a positive. Number between 2 and 5, 3. 3 minus 5, 3 minus 2. Negative times a positive is a negative. F prime is 6. 6 minus 5, 6 minus 2 is a positive. So right here we're looking at this. So the particle is moving right where you see the positives. From 0 to 2, union, 5 to infinity. And it's moving left when it's negative, which is going to be from 2 to 5. Okay, now we're going to see when the particle is changing directions. So we're seeing it's going to be changing directions at 2 and 5. So let's see at what position that takes place. So changing directions. Is going to be at 2s of 2. And then you're going to have 5s of 5. Okay, so our original function. So you can either do it here. I put the graph in here. It's right there. Algebraically speaking, though, it's going to be 2 times 2 cubed minus 21, 2 squared plus 60 times 2 plus 3, which is going to turn out to be 55. Okay, and then we're going to see what S of 5 is. So you're going to have 5, 2 times 5 cubed minus 21 times 5 squared plus 60 times 5 plus 3. And that's going to turn out to be 5/28. Okay, so this is changed. So it's changing direction. When it's at 55 at t equals 2, and at position 28 when t equals 5. So 28 meters at t equals 5 seconds. Lastly, we're going to see when the particle is slowing up and slowing down. So then we look at acceleration. Okay, so acceleration was 12t minus 42. Okay, so we're going to be looking at our graph. Okay, so set this equal to 0 to see where it's crossing. 12t minus 42. So 42 equals 12t. T equals 3.5. Or 7/2. And so now you're going to test this using the sign chart. Okay, so you got 0 to 3.5. F double prime of 1 is going to be 12 times 1 minus 42, which is going to be a negative, and 3.5 to infinity is going to be F double prime of 4, which is going to be 12 times 4, which is 48, minus 42, which is a positive. So now let's compare our notes right here. So we have 0 to 3.5 and 5. Okay? So I'm just using the sign chart, going to reference that sign chart. So velocity, we'll do acceleration first. Well, I guess it doesn't matter. So velocity is positive from 0 to 2. That's 0. 0 to 2. And 2 to 5. 2 to 5. I mean, it's negative from 2 to 5. My bad. So it's positive 0 to 2, and then it's negative from 2 to 5. Okay? and then it's positive 5 and on. Okay, these are negatives. Acceleration is negative from 0 to 3.5 and positive 3.5 and on. So the particle is speeding up when the signs are the same. So from 2 to 3.5 union 3.5 to 5. I'm sorry, this is when the signs are the same. This is slowing down. So since the signs are opposite, okay, starting over. Sorry. That is a negative, that is a negative. Speeding up. So this is when the signs are the same. So you have a negative, negative, 2 to 3.5. And then a positive, positive, 5 to infinity. Slowing down is going to be 0 to 2, union 3.5 to 5. Okay? Now, we're going to write all this in a paragraph form. So, first thing, we've got to see where the object starts, and that's going to be at the y-intercept. So, object starts at s equals 3 meters when t equals 0. Okay, so you just find that by putting 0 into the original function s. N moves right until it stops at s equals 55 meters when t equals 2. Then it moves left to the point s equals 28 meters when t equals 5. Where it stops again. Critical points. And finally, continues right from there on. Okay, so that's enough for this lesson. Please see your homework in your email. If you have any questions, let me know.